All right, everyone. I think we can start. So I welcome you on the next lecture for Node.js. Today we're going to be looking at something that is, I think, one of the most important things we can do in backend, which is logging and error handling. So before we begin, what would be the agenda? Yeah, as usual, that's me. And the agenda for today's lecture would be the following. We'll look into what logging is, why it's the most important thing that we can have on our backend, different types of loggers, so like libraries or approaches that we can have in a typical production application. Because it's very important to be familiar with the things that are currently used. And also we'll look into error handling, types of errors that we can have, because it's not just throwing random stuff at the developers or users. It's all about kind of having a certain structure there. And so let's start with logging. Basically, since you might know from your front-end experience or in general JavaScript experience, we have something called console.log, which is almost like an abbreviation for put something out of the program on the screen so I can see what's happening inside. It's used for logging, it's used for debugging, it's used for formatting, anything that you can think of. But in actuality, you don't often see with Node.js application or backend application, you don't usually see the output so much, especially when you have not just one server, but a number of servers. And they can do the same thing. So it's either a scaled server, or they can completely be separate from each other in terms of what they do. For example, payment server and authentication server, or I don't know, data access server, anything like that. So all in all, they'll be generating a whole bunch of different stuff, and basically all that information should be at least structured so that we don't see different formatting among all the servers that we can have.
some environment for.
How long have I been muted?
Some environment for testing, some environment for pre-production testing, and to run some tests.
2 minutes.
Okay.
Okay, so let's start from the beginning again. Logging is something that we need to have consistent across all the applications, different types of applications, or the same application but scaled at some point. We need to have several different things that will help us, no matter what we log, will help us to pinpoint the location where that log have been created, the timestamp, so when it has been created, and some level to kind of indicate whether we should ignore this log statement. Is it just an informational thing, or it's a critical error and something might go wrong if we don't act upon? So hopefully most of the information I discussed on this slide was clear without the muting thing. But anyways, so an interesting thing, the least spoken of, I think, at least when I first started with logging, was level. So with timestamp, it's just a date. It could be something as simple as the UTC format of date, or could be an actual timestamp in milliseconds, microseconds, etc. So it depends. But anyway, this important, like 3 important pieces, like every log should have, is usually delegated to libraries. So before we go into libraries, we'll briefly touch the levels. So levels are kind of like indication of methods for HTTP. Within HTTP protocol, we have get, post, put, delete, etc., and they have some impact on, over the way that the request should be handled. Kind of the same thing happens with log levels. It's a special field in the log itself. It's either level or status or something like that, usually level, that indicates like potentially how should log be created, aggregated, and acted upon. It is usually either a string that says debug info warn error or fatal, or it could be a number like 1 to 5, or usually 100 to 500 something. So it depends on the way that the library is going to do that. They all kind of, the picture depicts how the fatality or seriousness or priority of logs escalates within each of the levels. So fatal errors are the ones that usually, or fatal errors are the ones that are usually kind of like aggregated. Fatal ones are those where people should act quickly. For example, when someone is on duty, kind of like one person who looks at all the graphs and some kind of metrics to see how the servers are doing, and in case of the fatal error, that probably means that the application is due to shut down or should be shut down and restarted, and that person should do that. So fatal errors are kind of like urgent, high things that require hotfix or restart of the server. Typical errors are usually the ones that create bugs within projects. Warnings are those things that could potentially cause harm or indicate some security violations, for example. So it's not a security incident, it's a security violation that could cause something. For example, we see that warning that some library is outdated sometimes with npm, but this one is for the backend. So it could be some, I don't know, rate limiting indication that the third party for the server is throwing, and that may potentially impact our application. Info, it's the thing that help us navigate our logs. So usually it's a high-level indication of where the log or the process is currently at. So usually very interesting thing to kind of like think about and organize beforehand, so that you kind of like have an easier time, or that person on the duty call or pager duty has easier time to kind of pinpointing where the error happened. So they're always welcome. But beyond the warning, and I think beyond error, everything above is optional, especially debug ones. So debug ones are usually only enabled for, as you might know, not env equal development. So for development environment, those debug statements that help us to kind of like see what's inside the requests, see what's inside the payloads, etc., etc. And if we use this level within the library that we're using for logging, it will be automatically disabled when we go into production. So that's a kind of a neat feature. And that's what I meant when I started discussion about protocols or agreements on the engineers, backend engineers that they had. So these levels, they're unified. They're mostly kind of language agnostic. So logging levels that we have in Node.js are similar to those in Java application, .NET, etc., etc. Even those numbers, not necessarily string indication, but numbers that correspond to those log levels could be found in anything, even like routers and switches. So same idea across the whole stack, basically. Okay, so the first one that we might look into is actually like the tiniest of them all, library that gets us what we need, basically, telling us where that happened, what happened, and kind of like how much time it took. The timestamp could also be the same, and it tightly coupled to the way that Node as a platform itself is debugged. So at some point we needed to debug our application, set up some breakpoints, and etc., etc. But since we're working with JavaScript, we don't usually have that functionality like we have in, I don't know, C# with Visual Studio, where we can have the compilation level breakpoints, or similarly what we have in the browsers when we work with front end, where we can have directly in the browser a number of breakpoints. With Node.js, since it's like JavaScript without all those additional features, we're lacking that ability to debug and log stuff. By default, there's only console log thing, or std out, which is standard output, which is another name for console log. As usual, those engineers who kind of like created Node.js, they thought that having the same functionality that works for front-end development with breakpoints would be nice. So there is a way to kind of like, it looks similarly to this statement. So there is a way to launch a Node.js process with a specific file in a debug mode that will open up browser and lets you to kind of set up that kind of breakpoint code and execute different debugging techniques that you might be familiar with. And from that idea, because it kind of standardizes the way that we debug and set up breakpoints in our JavaScript application, how the debug library was born. We took the similar approach. We took the console logging with additional features that are enabled by default, and we created the library. So that's the first thing we have, and this is how we use it. So the debug library itself, it exposes a function that allows us to pass some kind of name of the module that it will in turn decorate with those additional statements. And it will allow you to toggle the debug output from different parts of your module. So quite handy, but it's simple as that. So we expose a function, then we potentially optionally name this kind of logging flow, and then we can have something logged on. So this logging flow, as far as I remember, would be this first line, and the ones that we're passing is actually this thing. So yeah, that's how it looks. Yeah, I was right. So as you can see, we are requiring a debug. Don't mind the common JS. It's now it looks a bit simpler than that, and it's usually on the separate line where we set up the name so that it's more obvious. But as you can see, this name corresponds to the colored version. Yeah, and by the way, with all the logging libraries, with all the functionality, the idea of having lots of logs being just a blank sheet of lines with without any coloring or formatting is painful. So at some point, those libraries will require some formatting so that we can have kind of separate statements wrapped in some brackets or with some additional features like pluses and minuses, and especially which is not supported by all the terminals, but sometimes the output will be colored, and you can control the coloring of that output to kind of help you to distinguish between the different logs. As far as I remember, debug sets up its own coloring and it distinguishes the different colors from one another by the name of your server or the name of your module that we pass here. So features, it's simplest, minimum dependencies. It can create multiple loggers with different IDs, those names that we've seen. But it doesn't have any kind of like log level. So that means that it is a step up from console log, but I don't have ability to kind of separately debug and have some logging available in development and then automatically have those logs disabled and not appear in production. So that level of debugging or debug levels are not there in the debug library. Outputs to standard error stream. So basically, you might know that working with file system, etc., we can log either to the file, like the old days most of the system would do, like simple txt files or some special formatting files that will create those logs. Sometimes when you install some applications on your home PC or laptop, you might get some errors in the application, and they will say that, hey, look at the debug logs, they're stored somewhere, and that's one of the destinations. For debug library, the destination is set to the standard error stream. For Node.js, the standard error stream is that terminal, the console that we see when we launch our process, and standard input and standard output is the same. So it's kind of like destination, and the name standard error stream or standard output stream or standard input stream is more about computer science terminology than specific for Node.js. So keep in mind that different languages will have the same name for the standard output or standard input. It will mean the same thing, but the insides of the language itself will have the standard error stream or standard output stream access within the different modules or ways, etc., etc. For Node.js, an access to standard output or standard error stream would be through console log or console.error usually. So under debug, potentially they use console log somewhere under the hood. So, and it's mostly used for debugging purposes, so not logging per se, but debugging. The next one, so we're moving a bit further into logging realm. So instead of just logging some things, we try to organize it even more. So the next library that we'll discuss is Bunyan. Bunyan is simple and fast a JSON logging library. It has a CLI tool that allows us to control it. But the main point here is JSON. So just a couple slides ago, we saw typical logs that we have using debug. They look kind of okay, but similar to console log. And standard input and standard output is agnostic to the formatting. So using console log or debug, you essentially output text, unstructured, hard to parse text into your destination, which is in this case is a standard output. That means if I want to have a some kind of script, analytics script or aggregation script, or just a simple query script that will go through my logs and find specific things, for example, all the log statements for the app server, I will have to, in just line by line, parse it. So, for example, JavaScript function that divides a string into multiple substrings by empty space, and then recognize, which is compare this string to the one that I'm looking for, and then again output something. That's kind of a lot of work. Old systems, for example, the routers, switches that don't have ability to be that smart, they were forced to do that. They were using syslogs, as far as I remember. So simple text, unstructured, hard to parse logs. With Bunyan, we kind of try to solve the structuring and parsing of the logs. So how does it look when we try to use Bunyan? So when we import it, it exposes an object, and that object will contain lots of different useful functionalities and function methods, properties, one of which is function that creates a logger. So similarly to Debug Library, we can have different instances of our logger for different purposes. For example, logging one controller and then using a different one to log another controller, and they will have their own separate ways of logging, for example. And then after that, when we have that log object instance, we will use, instead of just log, like console log, etc., etc., will use actual methods that under the hood will do similar thing. However, what is different about them is that they will have different level values. So info will print something like level 30. For warn, you will have level 40. And as you can see, starting from 10 all the way to 50 or 60 will have different log levels, and it will all be printed in a pretty JSON formatted way. So any log aggregation or log display or log analyzers or query engines that understand JSON will be able to understand your logs, even if they're not written specifically to read logs of your application, which is a huge step up in terms of analyzing logs. So as you can see, library allows us to create instances with different names and then call methods that correspond to logging levels. So now, instead of strings, we'll have JSON object. They will be stringified, as you can see, when we send them somewhere. For example, different destination apart from standard output. But the main thing is that we can just JSON parse the log and have access to all the fields with ease. And the search functionality of the access is much simpler. So that was kind of the main selling point for Bunyan at the time, which is their manifesto of server logs that were previously just those text unformatted syslogs. They went a step up and create a structured logging, and you will probably encounter this combination of words structured logging a lot. Recently, they've been using those structured logging for all the machine learning, log analytics, etc., etc. So JSON is a standard among other languages as well, and it is a good thing to use it when you log stuff. So yeah, that's kind of like just reiterating the thing that we will have just the stringify method called when we need to send it through the web, and parse when we kind of want to analyze them. Some features of Bunyan library, an elegant log methods. The API with log levels is amazing. It has accessible string system for controlling where logs records go. So this is the destinations that I talked about. So whether it's a terminal with your standard output, or whether it's a file, or it's some kind of HTTP endpoint. So whether you're sending it directly somewhere outside of your stack or a different server, Bunyan can be used to easily control where records are sent. So you can have development environment storing logs in terminal or file, and then for production, you'll be sending those production logs directly to a specific server that is up and running to ingest all the logs of your system, for example. A really nice way to aggregate logs and then analyze them. It has some serializers, those functions that allow to stringify and parse the logs back and forth. It supports different runtimes. Yeah, I think we covered all the features already. It can have special log instances like log child, for example. So by going back to the example, when I create the logger with some name, I can have I can create its child to kind of indicate in the name itself, in the log itself, that it belongs to a specific logger instance, for example. So if I need those beautiful nesting in my application logs. The next one, sorry, excuse me. All right, so the next one, the next logger that we have is Winston. Winston is a kind of a parallel project that was developed kind of with a different focus. And the focus of Winston is to cover all the features, all the possible ways that we can have logs aggregated, analyzed, etc., within our application. It's a multi-transport async logging, so it's kind of like a different API if you require that. It has more features than Boolean. It can output in different formats, so it can do JSON, can do text. So it really kind of like nice library when you need lots of features and you have a really complex system with different levels of logging, so that you can gradually kind of like construct your logging system. So this is how we use it. As you can see directly, we can have Boolean output the text in here, and the way that we output is actually controlled by the format method within the library itself. So it exposes Winston object. It will have all the needed things inside. So as you can see, I have logger library imported, then I can control how it exports, how it logs into the stream, and it will be controlled by the logger instance itself. I have different levels, which is info, error, debug, and I also, as you can see, can create my own logger. So it is a standard one, but if I want to kind of that's just for like the lazy people, I think, lazy developers who just want to plug it and use it directly. As you can see, it's has lots of default fields that we talked about, which is a timestamp, some level, etc. But a way to go usually is to create your own logger, which where you control everything. So formats, so JSON instead of just simple logs with text, different transports, and as you can see, it's asynchronous, meaning that I can write everything into a file using for specific errors, for example. So I can control where my errors go and where my where everything else goes, basically, to kind of like pinpoint. Also, those levels will allow me to, at the same time, send my logs somewhere to the analytics server. So instead of actually aggregating logs, I'm now able to not only aggregate, but also separate what should be aggregated and where, because analytics servers are not really for kind of like errors. They are all for the positive outcomes, so that we can kind of have decisions for machine learning and train those machine learning algorithms correctly without mixing some errors. So really nice way to decide specific things that your application needs. Again, food transports, which is a killer feature, I think, of Winston, control over transport. As you can see, we're writing both files with different intentions, with different log levels for our own development, for errors in production. This one won't be available when we deploy to production. And the info goes directly to console, so kind of like we don't want to have lots of meaningless data that is there just to provide debugging or, I don't know, helpful functionality in the file, because those files will grow exponentially larger and larger. So really nice feature. At the same time, as you can see, we can have it colorized. We can have timestamp enabled or disabled if we need that, for example. So yeah, a bit more of examples. We can have instead of the standard way of formatting, or instead of standard way of timestamp, for almost every, I think that's a good correction here, for almost everything that we can have configured in Winston, whether it's transports or whether it's other options, we can provide our own functions that will do that work if we need a really specific thing to be there. So without actually relying on Winston to provide everything that we need. And also, it also works for serialization, which is a most popular way of configuring Winston with a kind of like constant function. So again, features. There are a lot, but the main thing is that it is a performant way of logging, so it doesn't really go within the same process usually, or within the same stream, and those streams are not singular. There could be multiple streams of logs going in different ways without actually blocking main application. So think of the child processes that Node.js can spawn to handle those logs, and Winston does it for you. It also has ability to direct and store logs in different locations at the same time, and those directions or destinations, they're usually called in the logging libraries. Within Winston, we use transports for them. Again, advanced features for formatting, either providing your own formatting or relying on the ones that are pre-written by Winston team. And also log levels. There are also log levels, as well as metadata, which could be used to add additional logic on the analytics servers. And finally, for the logging, we can have something a bit different from what we discussed already. This is Morgan. Morgan is a library, but it doesn't have the same API that we've seen. We don't usually use Morgan as a kind of like a plug and go thing anywhere in the code. Morgan is specifically to log using middleware system of your framework of choosing. Usually the combination is Express plus Morgan middleware, and that middleware could allow us to, again, control the request response level of logs and output them within different formats. So the main focus here is to have only request response related logs. So whenever something hits the server, whenever we respond with some information, we want that information to be outputted in a similar fashion. And because it's a middleware, we can plug it in every router, or we can have it globally, we can have it locally within different flavors. So combined here, we'll have one format, but we can control it directly. So that function will be typically called with 3 parameters. And again, yeah, that's like the main difference of Morgan as a library for logging, is that it is primarily for middleware. There are a bunch of tokens, and tokens in Morgan, they are kind of like predefined dynamic values that you can have. So instead of constructing actual strings and getting those data directly from request response, so kind of mapping it onto your log statements, you just use a standard way that Morgan provides you with for dynamic values. You can switch them, change places, add some additional formatting, add some dashes, dots, etc., etc. But Morgan, since it has the syntax enabled, will be able to analyze your request and response and actually parse it correctly. So you might think that those tokens kind of limiting, they are in some way, but it allows you to kind of like focus on the order of things and the way it looks in your output stream instead of actually focusing where and what you need to kind of like extract from your request or response. So features. It's ideal for middleware-backed libraries like Express. So whenever you have a middleware-enabled system, Express is one of them and the main one, I think. You use Morgan. If you have lots of logic hidden behind those middlewares in your Express project, Morgan will be ideal for logging. If you have kind of like request response logging based logs and not necessarily some custom logs, Morgan again is ideal out of the box solution. It has some ability to switch streams or log destinations, but it's limited compared to Bunyan and Winston, and has some predefined logging as well as the ability for you to define your own tokens. But again, it's not necessarily the ones that you can be used a lot. Those tokens and libraries that are based on those tokens and the additional features, utility functions, they are pretty much enough for most of the cases. So think of it as a way to just plug it at the highest possible level. For example, at app level, as we saw on one of the previous slides, on app level, we have that Morgan middleware with a predefined format, and we can just simply forget about the rest of the application because everything that comes and goes inside or outside of our application will be logged in some predefined format. So at this point, I need to ask you whether you have any questions regarding logging. If not, we'll be going into error handling because there are some quirks there. All right. Seems like no questions so far. Just remember that logging is home task asks for log. Yeah, that's actually why we have this lecture here, so that we kind of understand why we have this logging. So add express middleware, which will log service methods has been invoked and which arguments have been passed to it. Does that appeal to Morgan? Yeah, could be. That's for you to decide. Again, middlewares are functions that we can have expressed to kind of like sit in between the actual controllers and requests or requests themselves in response. In those functions, you can either use something like Morgan. So you're not even creating your own middleware, you just have Morgan plugged in. Or you can have those middleware functions written by yourself, and inside of that function, inside of that middleware, your own logging solution. So Winston, Bunyan, debug, whatever you choose to do. So it's up to you. I'd suggest to try both Morgan and Winston, Bunyan, etc. So pre-written middleware logging solution and your own middleware, because writing middlewares in Express is essential. Some of people I know might agree with. So yeah. Okay, let's move to error handling. I mean, when I started with Node.js and backend development in general, I've been seeing that combination of words, error handling. And I don't quite get why we need to handle those errors. But at some point, I dug a lot of the information and dug enough to kind of understand what confusion this kind of like words might cause. Why do we need error to handle errors in our application? What is handling? So essentially, errors are things that happen in our application. They could be random, like something went wrong and our application just crashed, or some error appeared and it was okay. It was the application just kept working, nothing happened. So what do we actually want to achieve? Do we want to rely on our application always running correctly without any errors, and if one happens, just restart it? Like, why bother? Or we have some way of notifying that something went wrong and either handle it in terms of like keeping track of what went wrong and gracefully, which is in a controlled way, shutting down the server, finishing all the tasks that were there at that moment, and then restarting it by itself. Or even better, just logging those errors and keep working, containing the errors in a closed space, for example, in a single controller. What is better? And that's what we call error handling. So instead of just closing the process, throwing a bunch of red errors into console without actually giving additional information to those people who will handle the the consequences of your server crash, or have your server gracefully log everything it knows, finish everything it was doing, so that no other users suffer from error happening because of the code that we write, and then restarting it again so that we have everything that we need. Error handling is exactly what I just described. So how do we do error handling? So different types of errors, they cause different types of things in our application, and we need to log them. We need to do something to prevent errors spreading, and we need to make sure that our server is actually able to shut down gracefully and be restarted again. So operation errors, like the one that we might have in terms of the networking, in terms of the, I don't know, infrastructure, etc., etc. Those errors are essentially out of our program control, so we cannot control how the infrastructure works out from the inside of the application itself. We also cannot control whether users have slow connection or fast connection, whether they're losing packets or not. So those operational errors are outside of that control. The operational errors could be, or we can have programming errors. Those errors that we might fix before shipping. So it kind of like, if it happens, that means our code could be written in a good way into, I don't know, a more robust system, so that this is in our control. And what's in our control should not be handled, it should be fixed, basically. If we know that there is a programming error, that error should be definitely fixed. But what's outside of our control should be handled instead of being fixed. We cannot fix network, we cannot fix infrastructure going down. But what we can do is handle the error in a graceful way, logging, shutting down, finishing all the process, and then restarting. That's what handling means. Not fixing, not preventing, but responding in a controlled way. It's sort of like when someone is shouting at you, instead of going nuts and shouting back, basically failing at your error handling, you gracefully explain your position and either move on, which is best, or I don't know, continue working without actually giving slight hint of or hindrance to the situation. So this is what handling means. We cannot fix that person shouting, but we can actually control how we what we do. We can fix what is inside of ourselves, which is programming errors. They are basically bugs in our system. So when we do handling, let's go closer to the actual kind of error handling in terms of code. What should be done? We should throw errors, generate exceptions, so that errors are not swallowed in. If something went wrong, we need to take note of that. So they are only used for synchronous actions, because throwing an arrow is asynchronous, kind of like a way of things. Invoke an error first callback. You might have remember that one of the first lectures we had, or Express one, they have a way of writing functions or callbacks in a specific way where we directly have access to errors, potential errors. And if they're present, we need to do something about them. So typical standard for Node.js model, Node.js application, or per se, it's asynchronous scenarios. So errors that happen as a result of a synchronous action. They also should not be lost, but should be waited somewhere in your asynchronous queue and then acted upon. Usual thing is error early returns with logging what happened. Reject a promise. So we're not doing just happy path programming. We should be also covering the rejection of promises. And common for everything is to generate or create an error event. We'll work with something like event emitters or some other state management kind of thing in your servers, or communication management, I should say, in our servers. So these are the options that we need to have in our application for everything. A bunch of examples for each of the cases. So for something synchronous, we use try catch, so that if anything happens in this operation, we're not throwing random stack trace thing somewhere. We control how it is displayed. For example, this one uses a pretty standard and lackluster approach using console log, not having console.error for that. But at least it caught the error, so in this code. Or if it's something like asynchronous, we're not able to do anything about that. So as you can see, this is the output of this statement. So something happened here, and we decided what should be the output. We caught the error. We're not directly outputting it, but we're outputting something, which is kind of like standing in between the error happened and user-friendly or developer-friendly notes that, hey, go fix here. For try and catch, as you can see, for asynchronous case, it doesn't work. Something happens along the line, try catch is no longer in control, and then we end up having a nasty stack trace. That's not just a ugly and not helpful thing to have, but also all those stack traces are usually considered a security violation. So to go with security compliances, to go along with security compliances for serious projects, we need to have correct error handling. So you might notice that correct error handling for backend systems is one of the OWASP considerations for security things. So for asynchronous stuff, to do the error handling, we have error first callbacks, and this is what we call a early return. So if error object is not empty, we console log or we log something. So this is the place that we do graceful shutdown or graceful something, no matter the handling errors, which is like logging, shutting down all the promises, etc., etc. And then we immediately return from the function instead of going deeper. So a very typical way to write callback functions that have errors built in. Promise rejections is becoming like a thing, I think, for the last 5 years in Node.js, which is when we either introduced promise API complete support for Node.js or had some polyfills written to promisify every possible library that we can have. And the key point here is to handle errors in your promises or rejections. So you might have seen someone writing asynchronous promise-like code with just then functions. So it's happy path programming. It's not the thing for real servers. If something is wrong, we need to know that this is wrong. Uncaught promises can sometimes cause your service to slow down because they stack somewhere in memory and they are unhandled. So handling of hanging promises is another thing that we'll discuss in one of the next slides. But this is all about promise rejection. So remember to reject your promises and handle what happens when we reject that. Error events, if we use something like event bus or communication bus or communication in your different processes or different servers, this is a really nice thing to have. Those bus are usually created with event emitter or something that is built on top of event emitter, which is server.on function. It is sort of like it has some event emitter functionality under the hood. So they also have error first callbacks. So we need to be aware of those as well. And finally, uncaught exceptions, those hanging promises. For example, imagine that we did the logging. We log everything that happens, whether it's good or bad. We handle errors, so we throw exceptions when needed. We do the rejection of promises. We do everything, but then we just shut down. Seems okay. We did most of the best practices stuff. We have the timestamps, so logging is good. We throw all the errors. We don't miss anything, but we're not gracefully shutting down completely. We're just shutting down and restarting. That means all those promises that were in progress at that point were kind of uncaught or unhandled. And uncaught exception is one of those things that we need to handle. So our Node.js application will keep track of all those promises, and it actually will issue if something is wrong, if some promises are unhandled or uncaught, those exceptions of those promises. But since we're not handling it, it will not do anything and will just shut down. Again, I repeat, that's one of the main problems that we might have, especially in the asynchronous world and asynchronous microservices architectures. So a very nice thing to do is to kind of like, if something went wrong, we should not try to restore the program's normal operation, but we just need to log those uncaught exceptions, things that we forgot, or cancel those, or not cancel, but at least wait for some resolution of those promises before we shut down. So, and that's usually done at the application level, meaning like top level of your application. It's not something that you would write like here when in a specific place of your controller logic, for example. It's usually on the app.js or server.js level. And I think that's it for today's lecture. It was a pretty lengthy one, but that's a topic that we sometimes forget to cover when we learn about Node.js. Those standard things that we discuss, like system logs, structured logs with JSON, is a major thing to kind of like understand in modern backend development. So, do you have any questions so far? All right. So my general recommendation is to first always do logging. So no matter where you are, if it's an already existing backend project or a full stack project, it might have logging. If it doesn't, just introduce one. In your pet projects also, try to use a specific logging solution, a mature logging solution instead of just console logging. It will help you tremendously, and you will learn a bunch of quirks that those libraries have. And lastly, libraries. There is no kind of like one kill or one library for all the cases. You might need to think twice before you introduce a specific library, and think about the bundle size overhead, as well as the transport and features that are available to you, whether you need that level of formatting, whether you need that level of control of the destination of your logs, etc., etc. But please do set up logging. You never know when you're going to need to analyze or aggregate those logs, and simply console logging won't be enough. Thank you for your attention, and I'll see you on the next lecture. Bye.